All right, so here are a couple of real world applications, right? So this is marginal revenue, which if you're taking business, you almost certainly know marginal revenue, kind of like the revenue at the margins. How much more revenue do you get if you add one more unit? So revenue is always the price of something times the quantity of something that was sold, right? So you can see it's a product of functions here. In this one, I have a relatively nice function, right? So I told you that P of t was equal to 100 plus 0.1 t squared, and Q of t was equal to 1,000 minus 2t. So you could really easily expand this out if you wanted to, but I'm just going to do a little chain rule. All right, so we know that r prime of t is going to be our second function times the derivative of our first function plus the second function times the derivative of our second function. T's, because I have t's in here. All right, so this is going to be pretty nice and easy, right? Because this is a term-by-term differentiation. So that goes away. So I'm going to get 0.2t squared. So I'm going to have 1,000 minus 2t times that. This is also going to be a term-by-term differentiation, so that goes away. I'm just left with the -2. So I'm going to put a -2 out front, 100 plus 0.1 t squared. So here's our marginal revenue. We could definitely clean this up a bunch. Let me actually write it out as a little bit of a nicer function. So I'm gonna just distribute this to both pieces. So 2/10 times 1,000 is going to be 200 t squared minus 2 times that is going to be minus 0.4 t cubed minus 200 minus 0.2 t squared. And then I can do some subtraction if I wanted to. I'm going to get 200 minus 2/10 is going to be 199.8 t squared. I'm actually going to write this in standard form. So I'm going to put a minus 4t cubed, or minus 0.4t cubed first, plus that minus 200. There's our marginal revenue.